Yeah, so we have another section that we want to cover. This is going to be section 6.5. So far we talked about how to factor it if it had 4 terms. That was the grouping method learned in 6.1. Then we learned if it had 3 terms, and we know for 3 terms we had 3 different options. We had shortcut, which is 6.2, but that's only good if you have no leading coefficient. And then the other type, which we knew as the FOIL, which is in 6.3, and the AC method, or the arch method, 6.4, they work for any trinomial. But what happens if you don't have 3 terms, but you only have 2 terms? So this is the last type of factoring that we have to talk about. If you have 2 terms, we're going to be calling something called difference of squares. And so this method works if we have 2 terms. Remember, if it's 4 terms grouping, 3 terms, you choose shortcut, arch, FOIL. But if it's 2 terms, we have to do difference of squares. Now, just like in all the other types of factoring, your first step was always look to see if there's a GCF first. Remember, A through D. Once you decide if there was a GCF, or even if there wasn't a GCF and looking at the leftovers, what you're going to do when you have 2 terms is you're going to have to see if the problem meets 2 conditions. If it does not meet the 2 conditions here, we cannot continue on. You would say that the problem is either prime, if you couldn't take out a GCF, or if you were able to take out a GCF, then that's going to be your final answer. You just can't do the additional difference of squares. So what are those 2 conditions? The first condition is that the 2 terms must have a subtraction sign between the terms. Okay? So if you had an addition sign, you cannot do these steps. The second condition is that all pieces, all the terms, have to be made up of perfect squares. I'll talk about that in a second. If you meet both of these conditions, not just one, but both, then you can factor out by doing the setup. Remember setup, where we're actually factoring our 2 sets of parentheses. When you do your 2 sets of parentheses, they're going to be binomials. We always have to have signs in our binomials. When it comes to difference of squares, it's always going to be 1 plus and 1 minus. Always different signs. Then what you do is you just find the square root of the first term, and then the square roots, the roots, will go in the first spot of each binomial. Then you're going to do the square root of the last term, or the second term we would say. And you put those roots here in the last spot of each binomial. So that would be considered factoring out the different squares. Now let me talk about this part. What do I mean by terms made up of perfect squares? So we have 2 different types of perfect squares that we got to talk about. We have for numbers, and we have for variables or letters. For numbers, here's your perfect square list. Starts with 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225. Now I kind of ran out of space. This could go on and on forever. So after 225 would be 256, and then you can keep on going down forever and ever. Now, how is this made up? How is it 4 and 9 and 16? What you're trying to do is think of 2 numbers that multiply, that are identical to each other, that make up this number, this square. So for example, the only factors that make up 1 is 1 times 1. For 4, even though 4 times 1 work, they're not identical factors. It has to be identical. So the only combo that works is 2 and 2. 9 is 3 times 3. And then you can start seeing the pattern, what I did. 1, 2, 3, 4. So you know this would be 5 times 5. And you can do it in your calculator. 6 times 6 would give you 36. 7 times 7. And then so forth. So if you see any of these numbers in black, they're a perfect square. That means you can think of 2 factors that are identical to each other that make up that number. The numbers that I'm writing in red are known as the root of the number. So 196, the square root would be 14. And then 225, the square root would be 15. And then of course the next one would be 16 times 16, which would have gotten us the 256. Now we also have to worry about the letters. So notice we don't have 2 numbers that we're trying to think. We're trying to think of 2 items that are identical that would give us a squared. So for a squared, we can do a times a. Remember how we said a times a is a squared? That's because 1 plus 1 is 2. Now for a to the 4th, remember you have 4 a's. How do you want them to look identical? Well, you're not going to put 3 a's here and 1 a here, because that's not identical. To be identical, you want to split it evenly. 2 here, 2 here. Because if you do 2 plus 2, you get a to the 4th, and they're identical to each other. Remember, this is the product rule where we add the exponents to get that number. So a to the 6th, that'd be 3 here and 3 here, because 3 plus 3 would give us the 6. Notice any variable that has an even number exponent, 2, 4, 6, if I had a to the 8th or a to the 10th, would be able to break it down evenly. Think of a to the 10th. 5 a's and another 5 a's here. So a fifth. Or a to the 10th, a to the 5th, a to the 5th, or a to the 20th, a10 and a10. Anything with a even number, just divide it in half and you'll be fine. Okay? So here's for the variables. Here's for the numbers. What's in red is known as the roots. Okay. So let's take an example. We'll take x squared minus 25. And let's say we had to factor that guy out. So we said that when you have x squared minus 25, it's a binomial that they're asking you to factor. The first thing you always want to do is check to see if there's a GCF. Okay? Every single problem, they had 4 terms, 3 terms, or 2 terms. That's your first step. So remember, when we're looking for GCF, we go for the alphabet, A for D. A, do you have matching set of parentheses? No. B, do you have the same letter in each term? No, this one doesn't have any letters. C, do you have the same number factor in each term? Remember, this doesn't have any numbers. We don't look at exponents. We look to see if there's a coefficient or constant. So no, doesn't have a common number factor. And then D, does it start with a negative? No. So even if it had a GCF or didn't have a GCF, you're going to count the number of terms left over. We see it's 2 terms. Before we start factoring, we have to see if it meets the 2 conditions. The first condition, is there a subtraction sign between the 2 terms? Yes, there is a subtraction sign between the 2 terms. So we met condition A. But we also have to meet condition B as well. Is all terms made up of perfect squares? So let's see if they're on the list. X squared, just like a squared. So it doesn't matter if this says z or w. X squared, perfect, because it has an even number exponent. And is 25 on the list? Yes, perfect. If this was a 17, even though this would be a perfect square, if this was 17, notice 17 is not on the list. It goes from 16 to 25. If one piece is not a perfect square, then you cannot meet condition B. Condition B says that you have to have all terms, not some terms. Luckily, we met A and B, so if we meet both conditions, then we can do the factoring. Now remember, factoring for us is working with parentheses, so we're going to do our setup. Our 2 sets of parentheses, and we're going to have a plus sign and a minus sign. Once we do the setup, remember, because of the minus sign, it's different signs here. Then we're going to do the square root of the first term. Now remember, x squared is the same thing as a squared. So if a squared is a and a, then x squared is going to be x and x. So they go in the first spot of each binomial. The next thing is 25. 25, remember, we want to put the roots in the parentheses, not the 25, but the roots. Remember, find the square root of the second term, place the roots in each of the binomials. So if I know 25, the root is 5, so I'm going to put it in both. Now, since this didn't have any GCF, this would be your final answer. Because they're different signs, you have to keep the 2 parentheses. I don't want to see x plus 5 as a square. Keep them because they're different signs. Keep them separate from each other. So that's how you would factor out this guy.